Hi, algebra friends. Okay, last review video of chapter 3. So, this video is pretty much just only going over part 2 of lesson 3.7. So, all we're going to be talking about today is how to solve an absolute value inequality. Now, remember, that looks something like this. So you've got absolute value bars, you've got an inequality sign. So that's pretty much what we're dealing with. Now, today in class, we only looked at the first portion of our acronym. So out of LAGO, we only looked at L and A, which is our less than, meaning that we set up an and inequality. So I'll go through that in the first part of the video. And then the second part, I'll talk about the second part of our acronym, greater than and or. So here we go. Okay, so we talked about this today. Now, all that your book is pretty much telling you here is that when you see an inequality that looks like this, you see a less than sign, you set up an and inequality. Okay, thus the first part of our acronym. When you see a greater than sign, we set up an or inequality. So less than and greater. Okay, you get the point, or. So here we go. Just for some quick rapid practice, if you see this one, you say that, okay, this is a less than sign. Because it's less than, we'll set up an and inequality. In our second one here, I see a greater than sign. Because it's greater than, I'll set up an or inequality. Again, we've got greater than or equal to, we'll set up an or. And lastly, we've got a less than, which means that we'll set up an and. Now, let's go through part 1. Part 1 is just talking about our less than, aka our and inequalities. When I see a problem like this, I'm like, okay, I see the less than sign, which means that it'll be and. Number 1, we've already got our absolute value bars isolated. That's good. That means that we can start to set up our and inequality. So I'm going to leave the x is less than 5. I don't know why that little line is right there. Ignore it. And then on the opposite end, we put the opposite of 5, which is -5. Now, that's actually your answer. Okay? That's all that you really had to do here. Now, we can also write that in interval notation. So remember, because it's just a less than, we would use parentheses. We got -5 and 5. And then if we want to go and graph it, put your two endpoints. Now remember, this is and, which means that we shade right in the middle. And because it's just a less than sign, we will use open circles here, and we will shade right in the middle. Okay, that one was pretty easy. Example 2, I see a less than sign, which means that it's going to be an and inequality. So right now I ask myself, are my absolute value bars isolated? They are. You don't see like the absolute value bars plus 3 or like 2 times the quantity within the absolute value bar. So they're isolated, which means that we can set up our stuff. So we've got x plus 3 is less than 5. And on the opposite end, we will put the opposite of positive 5, which is -5. Now, think back to a little bit ago when we were going through solving these and we drew our lines going down the sides here of our signs. We want to get x by itself. That's our entire goal that when we're doing this here. So we want this piece alone. To isolate that piece, all we need to do is go -3, -3, -3. That cancels out and I've got x right in the middle. 5 minus 3 is 2. -5, take away another 3 is a -8. Okay, and here's like part 1 of our answer. So there's your compound inequality. We can write it in interval notation, and we can graph it. So just put your two endpoints here, open circles, shade in the middle, and then we're good to go. All right, the last one of our and inequalities. We've got a less than or equal to. Here we are. Now, currently, your absolute value bars are isolated. So again, you're good to go. You're ready to set up this problem. So you've got 2f plus 9 is less than or equal to 13. On the opposite end, we'll put our -13. Let's draw our lines going down our inequality sign. So it kind of like, I don't know, it kind of like separates it into 3 parts. We want to get this f by itself. The first thing that we can do is we can subtract 9 from every portion here. So 13 minus 9 is 4. These cancel, and I just have 2f. And then when I do negative 13, take away another 9, I get a negative 22. Your last step to isolate f, because it's being multiplied to 2, we can divide every single piece by 2. So here we are. And now I've got negative 22 divided by 2 is negative 11, less than or equal to f, less than or equal to 2. So here's like part 1 of your answer. We can write it in interval notation. Now, because it's less than or equal to, we would use brackets. And we can graph it. And because it's a bracket and it involves that less than or equal to, these circles here will be closed. So these will be closed and we'll shade right in the middle. So that is how you solve an absolute value inequality with a less than sign. We set it up so that it's and. Now, part 2 is when you see an inequality that involves a greater than sign. This one's a little bit different. So take a look. Right now, I see, okay, this is a greater than sign, which means that we're setting up an or inequality. Step 1, isolate your absolute value bars. Lucky for us, that's already done. Once that happens, we set up 2 cases. So here are our 2 cases. The first case, you just rewrite everything that you see, just taking away the absolute value bars. So x is greater than 5. Because this is greater than, we need the word or. Okay, here's where it gets a little bit different. You're going to write the variable, flip your sign, make this the opposite. So this is keep, flip, opposite. Keep, flip, opposite, or keep, flip, change. This right here, this is what we need. X is greater than 5 or x is less than negative 5. To write that in interval notation, be careful. We always do our lower endpoint first. So it's going to go all the way to negative infinity and negative 5, parentheses, union, 5 off to infinity. This should be review. Then we can graph it. So again, we've got our negative 5. Because it's just a greater than sign here, which flips around a little bit, these will be open circles, and we will shade off into separate directions. If you were wondering, yes, I am wearing my Drake Christmas sweater. Of course I am. Why wouldn't I? You can't stop me. Okay, here we go. Number 2. So again, we see a greater than sign, which tells me right away that it's going to be an or inequality. So because our absolute value bars are already isolated, we can set up our 2 cases. First case, write it out exactly how you see it. Just take away your absolute value bars. Second case, keep the first part, change the sign direction, make this the opposite. Keep, change, opposite. Then we literally just solve normally. So it's almost like we just solve these separately. So you got x is greater than 2, or take away their 3, take away the 3, x is less than negative 8. Okay, again, there's like the first part of our answer. We'll write it in interval notation. So let's start with our lower endpoint, negative infinity, negative 8, union, 2 to infinity, and we can graph it. Now, again, these will be open circles. They go shooting off into here. And you're done. Okay, last one here. Let's also, I'm going to change this up really quick. I'm going to change this up. Hold on. Let's do, okay, just so you can see an example of like when we're not ready for the 2 cases. Okay. Right now, take a look at your sign. I see greater than. That tells me it's going to be an or. Are your absolute value bars isolated? Hopefully your answer is no. Do you see how you have this +1 here? We need to move that to the other side so we can get our absolute value bars by themselves. So we will take away 1 from both sides. Okay. Now you've got 2f plus 9, is greater than or equal to 13. Now your absolute value bars are isolated, so we can set up our 2 cases. Case number 1, Write it exactly how you see it. Just take away your bars. No, we're not spitting bars. We're taking away the bars. Case number 2, write your first part, like your first part right here, normal. Change your sign direction. Make this the opposite. And then let's just solve them separately. So we've got -9, -9. 2f is greater than or equal to 4. Wow, that's a very obnoxious color. Divide by 2. So f is greater than or equal to 2. Or, now let's go solve this one. Take away 9, take away 9. 2f is less than or equal to negative 22. Divide by 2. And you get that f is less than or equal to negative 11. So here's our answer. Wow, very obnoxious. So f is greater than or equal to 2, or f is less than or equal to negative 11. Let's do interval first. Here's our smaller endpoint. So negative infinity, negative 11, bracket, okay, bracket because it's less than or equal to. And then you'll also use a bracket here with the 2. But remember, no matter what, you'll only have a parentheses next to that infinity sign or the negative infinity because we can never encapsulate it. It goes on forever and ever. So we've got our answer here, interval. And then if we graph it, please don't mind the mess. Okay, these will be closed circles shooting off this way, closed circles shooting off this way. Okay, so just really quick to review. In this video, we talked about solving absolute value inequalities. Okay, absolute value inequalities. The acronym that we use to help us is LAGO. When we see a less than sign, that means to set up an and inequality. So like if you had interval notation, it would look something like this. When you see a greater than sign, we set up an or inequality. If you put it in interval notation, it would look something like this. Sure. Okay. When you're solving a less than or an and inequality, as soon as you isolate your absolute value bars, all you need to do is pretty much just solve, keep this number on the right side, put the opposite on the other side. Okay. When you're looking at the greater than or the or inequalities, isolate your absolute value bars and you've got to set up 2 cases. Your first case will just be exactly what you see without the absolute value bars. Your second case, keep the first part, like your variable or your expression, flip your sign, make the opposite. So just like we did here, we set up our 2 cases. This one looks exactly like what's above. It's pretty much the same thing, just no absolute value bars. The second one, we kept the x plus 3, flipped our sign, made the opposite. Okay, hopefully that helped you. If not, please message me and let me know. Thank you for listening. And as always, like, comment, subscribe. I'm just kidding. I know Scott's rolling his eyes upstairs. Okay, thanks, guys.